Hey, welcome back. I think this is going to be our last one. All right, let's talk about Earth's oldest organisms. There wasn't too many things happening in the Archean eon, but let's touch on it because this is where life got started. In fact, you've actually been looking at the Earth's oldest organisms this whole time. It's these little round things that you see in kind of barely in this kind of very subtle image in the background. Um, the first organisms were archaea and bacteria. Both consist of prokaryotic cells, which are cells that lack an internal structure. Um, they lack a membrane-bound nucleus and other structures. It was more like just a cell membrane and just a bunch of stuff floating around in there. However, so in 1954, structures known as stromatolites were discovered to be some of the oldest fossils on Earth. And those are again, these little round muffin-looking things in the background. Stromatolite literally means layered rock. So stromatolites are actually stony structures built by colonies of microscopic photosynthesizing organisms called cyanobacteria. And different types of stromatolites create different structures, but they're all these layered structures. Each kind of colony of bacteria build on each other to form these layered structures called stromatolites. Sometimes they're in these full mats. Sometimes they're in columns, or sometimes they're columns linked by mats. We still have stromatolites today. They're not 3.5 billion years old. They're newer than that, but we still have these organisms today. So here's an example. These are common in a couple of places around the world. I think the ones I'm going to be showing you are mostly in Australia. So this is what they look like. They're kind of exposed at some points, maybe at low tide, but at high tide they're just below the ocean level. So you can see each of those little stromatolites. Here's another example. Again, these layers of cyanobacteria kind of forming these sticky layers, these sticky mats that collect sediment, and then new layers, grow on top of that. New layers grow on top of that, and they kind of build up these layered stromatolites. So if you were to slice them in half, they would look something like this. Now these are actually ancient stromatolites. So we can see the structure of how they were created. These are actually 3.5 billion years old. So we find these in the rock records, and uniformitarianism, what we see going on today, stromatolites, we see in the past. So we can study these stromatolites presently, figure out what they are, and then figure out how they played a part in the world's past. So again, present-day stromatolites form and grow as sediment grains are trapped on sticky mats of these photosynthesizing cyanobacteria. So you get kind of sediment sticking to it, and then you get new colonies, sediment, new colonies, sediment, new colonies, sediment. So that's where that layering comes from. The oldest known stromatolites fossils are from the Warrawoona group in Australia, and these are almost 3.5 billion years old. And this area is located in the North Pole Dome, about 40 kilometers west of Marble Bar in Western Australia's Pilbara region. There's a lot of old stuff coming from Australia. Remember the Jack Hill zircon? That's from this area. That's from this area here. Shark Bay that has current stromatolites in Australia. So we get a lot of. Oh, anyway, getting back to those zircons, the Jack Hill zircons. Remember, those are the oldest Earth materials that we found. They're 4.4 billion years old. We don't have the rocks they eroded out of, but we have those. So now we have these ancient cyanobacteria stromatolites at the North Pole Dome. A lot of old stuff. Australia, very old craton. So here's an image of those of the North Hill Dome and the rocks that contain the stromatolites. So I just noticed this. and now that I look at this picture. But this is, if these guys here don't scream geologist, I don't know what does. Couple of things. One, the first thing that's sad. So geology is the most underrepresented science of minorities. So it's the least diverse of all the sciences. Least diverse is less diverse than physics, than engineering, than chemistry, than biology, which absolutely sucks. All right, the diversity in population in science means diversity in thought, means new ideas. Diversity is amazing for science. Unfortunately, geology is the least diverse of any of the science. It's mostly, as you can see here, old white dudes. So I'm not helping anything. What's funny, though, is that this is, I was just at a geology conference, and this is what every old white geologist wears, even in the city. I've been in the middle of big cities. Phoenix had a geology conference, Denver, Portland. I was just in Pasadena, so LA. But no matter what, these old white guys, they all wear these funny hats with the little flap on the back or the big brims, and they all got like cargo shorts on, and they all got hiking boots on, even in the middle of the city. Anyway, sorry, I digress. But anyway, they lead tourist trips to locations like this in Australia, which I would totally go to if I was there. And again, here's another cross section of those stromatolites where you can see this layering, this now petrified layering to indicate indicates stromatolite activity in this fossil. So again, how does it kind of work? So you get the organic components, the cyanobacteria, those microbes, collecting the little pieces of sediment to as they kind of collect and kind of cement each other together, they kind of form these layers, new ones grow on top, etc. This is kind of a zoomed in view of what we see. Kind of, this is more of a zoomed out view. So imagine the blue is water, and so you get this cyanobacteria. It's kind of hard to see these little green things here, and they're collecting little pieces of sediment to build up and build up and build up, and then you might get this structure buried. So buried under sediment, and that sediment lithifies, turns to stone. The fossil is created, and you get again things like what we see here. So what do these little cyanobacteria look like? Well, we have a picture. We have some images here. So photo micrographs from what these 3.5 billion year old Warrawoona group stromatolites show what these cyanobacteria look like. So we got pictures of them. And then here, these are just schematic restorations, drawings of what these cyanobacteria organisms look like based on their photographs. And you can see in this photograph, this is only 1/100th of a millimeter. So a millimeter is about how thick your fingernail is. Divide that by 100, and that's about how wide these cyanobacteria are. Tiny little things. Well, folks, guess what? That's the end. I know, that was a lot of Earth's history. That was, again, from Earth's creation about 4.54 billion years ago to through the Hadean and through the Archean, which ended about 2.5 billion years ago. So we're looking at, again, around 2 billion years worth of time, which is, I know, a long time. In fact, let me go back to that real quick. Here we were. Yeah. Let's switch it up a little bit. There we go. So that's what we covered. All right. So that's what we covered. In Unit 8, we're going to cover about another 2 billion years, the Proterozoic eon. A lot more going on, a lot more evidence as well. But that's what we'll go in Unit 8. Before I leave you, you might have noticed, like, wait a minute, he didn't give the super secret code. Well, there is none for this unit. I was just curious to see. If you're watching this to the end, good for you. But my guess, just a guess, a hunch, my guess is that there are some students who is like, oh, there's no super secret code, so I'm just going to look at the PowerPoint real quick and just write down some crap so I can be done with it. And I don't have to watch an hour and a half worth of videos. But here you are, having watched all those videos, at least I hope. So let's do this. Let's see who actually kind of watched the video. So when you type your response, all right, again, there's no code. When you type your response, just start off your response with the word, I don't know, hat. Hat. So just when you just start off with the word hat, boom, and then write your lecture response. So that way I know that you've been here to the end. Just curious. Let's see who sat it all the way out. So just type the word hat and just be done with it. All right, just hat, period. And enter, and then launch into your paragraph telling me, what you would say at dinner and whatnot. Okay, let's give that a try. Let's see what happens. I'm curious. But again, if you're watching this and you're hearing this, good on you. You've probably been sitting through the whole thing. Let's see who's trying to skirt around it. Because I did not put a code on there. Anyway, let's see what happens. So anyway, that'll be the end of it. Like I said, next unit we're going to play around in the Proterozoic eon. All right, and we'll cover almost, by the end of Unit 8, 4 billion years worth of Earth's history. But it's these last 542 million years, there's just so much information. There's just so much. So many more rocks, so many more fossils. We know so much more. So that's why we're going to kind of spread those out over the remaining units, okay? So anyway, it's been fun. It's been my pleasure. Remember, start off your lecture responses with the word hat, and then just launch into whatever you got to tell me. Until next time, I will see you around.